Hello everyone, I'm Michael Strauss from Creative MicroSystems. I'm the Vice President of Engineering. I work for Creative MicroSystems. We're a small company out of Waitsfield, Vermont, which was founded around 2005. And we are a high-tech company that provides a lot of solutions for hard-to-solve problems. We have a 12,000 square foot facility that has very unique capabilities. We have a microfabrication capability down on the bottom floor of our company, which is capable of creating custom sensors, doing work on existing silicon. Also, we have the capability to take those systems and turn them into a rapid prototyping system. So we can rapid prototype, we can make our own sensors. We also have a software development for both image fusion, image processing, computational vision, and also work a lot with highG survivability systems. We do our own optical designs also, and microfabrication for microfluidics and micro-optics. One of our biggest things that people come to us for is the hard-to-solve problems. We spend a lot of time with our customers listening to them. One of the cases that we had was working with MARSOC for a problem that they had for a night vision system. And instead of going out and building something, we listened to them. We used some of our IP that we had, plus some of our know-how to create a system that then was turned into a DARPA SOCOM project. So we spend a lot of time not only working with the customers to create a pull type market instead of pushing products on them, but also working in a lot of feedback loops in order to make sure that the project we are working on, we are giving them the solution that they want. Part of that, once we listen, like I said, we solve the problem with the guys. It's an iterative process. We work with them. We want to make sure that we are meeting all expectations, requirements, and that everyone's happy at the end of the project. Finally, we have the capability to do rapid prototyping, like I said, but also low rate initial production. So we're able to produce in small quantities to the theater, and then we have experience in working with the big primes on either licensing the technology or pushing that technology completely to them for a full production run with support from us. Some of the things we do is low light and augmented vision. Like I said, we're working on sunglass form factor concepts through DARPA. Right now we have the DARPA SOCOM project. We've had Navy projects. We do have an Air Force project also that we were just awarded for an augmented reality system. We specialize in low noise, low latency use of existing sensors, but also have the capability to create our own sensors if necessary. So we are pursuing a couple of custom sensor designs for low light imaging and multispectral imaging. We also have our own proprietary computational vision, image processing, and image fusion. And along with that, we create hardware, specialized hardware for miniaturization in order to make sure those algorithms are running in low latency, low power situations. And finally, some of our sensors that we're designing are a true analog, true hybrid, or true digital hybrid design, where instead of just overlaying digital on analog, we're creating analog imaging circuits with digital injection or peel out of those signals. Other technology that we work on is advanced displays. We do a lot of holographic image guide development. We're one of the few companies that do a true holographic optical element-based display. We put those in near-to-eye displays, weapon sights, and also have head-up display technology that's ready for use right now. We have a mature holographic full-color daylight readable display that you can come at our booth, 128 over here with the glowing plasma tube, if you want to check that out. That is ready to be integrated into projects today. We're continuing development of that system on internal funding for wide field of view and curved optics. We also have ultra-thin occluded displays that are less than 1 millimeter thick, including the optics out. So one of the things that we're building for our low light imaging is using those displays to reduce the optical chain. One last thing that we're working on that I said is augmented reality systems. We are working for effective situational awareness increase. Part of that is the TAC-P program we won to increase the situational awareness of JTACs, TAC-Ps, and combat controllers on the battlefield, in addition to their head-down display. We also do a lot of out-of-band tag track locate and covert comms. This covers a wide array of both passive and active, UV to RF, to terahertz to very long wave infrared, data infill, exfill using LPI, LPD techniques, also powering those with unique power systems using indigenous power, and integrating those into tactical and national assets. So that's about all I can talk about there. Come talk to us if you want to hear more about that. We are in booth 128. Are there any questions out there on what we do? I see there's some former colleagues in the crowd. That's it. Thank you. Oh, wait, I got a question. Yes, Dawn. How is this different from Google Glass? Google Glass was made to be a display outside of your vision and display ancillary information that supported what you were doing either from your phone or from other displays. With this is augmented reality where we're overlaying data that has impact on your view of the world. So anything that you need geographically tagged information, data will be displayed in a perspective that you need to figure out with your brain, where does that data sit out there? So it's where Google Glass was a secondary display, this provides extraordinary awareness of where that data is in your real space. Anything else? That's it. Thank you.